Now that we know that we're not violating any assumptions of linear modeling with this SAC mod, we can move on to interpreting it. So let's pull up the summary of this model object. Same as before, we've got a lot of these familiar pieces. Looking at the coefficients, we've got an intercept and a coefficient estimate for our predictor variable. Before, when we were dealing with a predictor variable that was in the form of different categories or different groups, R would take the first of those groups and assign that to the intercept. So the intercept became the first group. And then we would have coefficient estimates for the subsequent groups. If we just had one other group, it would just look like this. If we had two other groups, there would be another coefficient estimate here. With more groups, you just keep adding more coefficients. But in this case, that's not quite what's happening, but it is also kind of still what's happening. In this case, the intercept is the kind of estimated value when the predictor variable takes a value of 0. In grade school, they might have just described this as wherever the line crosses the y-axis, assuming that you've got that value of 0 is where your axis starts. That's why it's called this intercept. And so this is the 0 value for date. And then for every unit of date that we increase, we need to subtract this many units from our response variable, from the FM index in this case. And so thinking back to our equation, right, that we've got our intercept, beta 0, and we've got our slope in this case, beta 1, and we're trying to predict FM, which is y here, and our predictor variable is x, date. This is the equation that we're dealing with. This is what's being reported on here. And so if we're trying to come up with the FM index, we need to account for both the intercept and the coefficient estimate for date, as always. Right? To do this, let's try to just pick a point or a date and figure out what the estimated FM index should be. If we look at the plot of our data, let me drag this over. So there's a bit of a gap here, right about 2000 or 2200 years BP. So let's predict a point in that area. We didn't have any observations from that time period, so let's infer something. Let's predict what the FM index would have been in that range. So I'm going to make an object and call it FM index 2200 BP. This is what we're going to predict, the FM index at a date of 2200 BP. We don't have information on what the FM index was at that time. So let's use our model here to figure that out. In order to do this, we can just plug in the numbers, right? We see that the intercept is 1.18. We see that the coefficient here is negative 0.0006. But you can also, because all of this information and this output here is contained in the model object. And so what we can do is say, okay, with SACMod, our model object, put a $sign, and after the $sign, put coefficients. If you run this, it will return your intercept and your date coefficient. And it's because it's got two values in there, we then know that you can index it with brackets. If I do index 1, that returns the intercept. And if I index it with a value of 2, that returns the date. And so knowing that I can do this, I can just recreate the equation of y equals beta 0 or beta naught plus beta 1 times our predictor variable. And so if we want to calculate what the FM index is for 2200 BP, we can say, all right, give me the SACMod coefficient, the first one, beta naught, our intercept, and add that to the SACMod coefficient 2, the second one, but multiply it by 2200, because we're interested in what this FM index value is at the year 2200. So we take 2200 and we multiply it by the slope. We multiply it by the coefficient estimate for date, and then we add that to the intercept. And so basically we're saying take 1.183 and add that to the product of 2200 times negative 0.00067. If I run this, we now have an object that contains this estimated value. In this case, the estimated value is still being tagged as an intercept. That's just because of how the kind of R code worked out here. It's not the intercept. This is the predicted value. The predicted value for 2200 BP is negative 0.304. And so thinking about what that means in the context of our plot here, 2200 BP, right around this area, we're looking at a negative FM index, meaning that there's still slightly more mammals than fish in this time period. This is what linear models do. This is what they're capable of doing, using these coefficient estimates to predict values of whatever variable you're interested in. And so by simply understanding, again, this linear model, the equation that we've got here, that our estimate is the sum of beta naught and beta 1 times our predictor variable, that's how you can calculate these things. And that is what actually this model is all about. And that is what we then use to visualize the model.